of thin wall structure, and this is one of the gate question from recent year, and this question was bit lengthy question from torsion. Okay, so let's read the question what it says. A two cell wing box is shown in the figure. The cell walls are 1.5 mm thick and shear modulus G equal to 27 gigapascal. If the structure is subjected to a torque of 12 kilonewton meter, then the wall AD will experience a shear stress of magnitude. So guys, which is the wall AD? This is the wall AD, right? This is the wall AD. So they ask what is the shear stress induced in this wall AD. So in previous class also I told, uh, in thin wall structure usually what we find shear flow, right? And it is a multi-cell, right? And it is subjected to torque. So multi-cell means usually see this torque is applied here, what you, if you in your sense it is anti-clockwise, so we will take shear flow is also in the same direction, because usually we say shear flows are resultant of applied uh, um, moment or torque or shear forces. Okay, so this is my q1 shear flow in this section, and this is what q2. So that is a q1 and q2 shear flow. So what will be shear flow in wall AD, QAD? Can anyone tell what will be the shear flow? In last class also we have done. See in AD, if you go from D to A in section 1, there is a shear flow which is going D to A Q1. Then if you see the section 2, there is a shear flow which is coming A to D. It is what? Q2. So QAD will be what, guys? Can anyone tell what will be QAD? It will be Q2 minus Q1. Clear? Now guys, what they asked, they didn't ask QAD. In the problem they asked what? They asked what is the shear stress in wall AD. So it is tau AD. So what is the tau AD, guys? It is the QAD divided by what? Divided by what? The wall thickness, right? So wall thickness they given, right? It is uniform throughout section, so it is T. So guys, everybody, it is clear what is asked. Now guys, in this if you see q1 and q2 are unknown, what is given? The total applied torque is given and other dimensions are given. Okay, so guys, we know from Brad-Weather theory what is the T. T equal to 2a1 q1 plus 2a2 q2, right? For multi-cell structure. Now here guys, everything we will convert in Newton mm. So what is the torque given? 10 kilo Newton meter, right? So it is 10 to the power 6. Okay, so 12 into 10 to the power 6, it will become Newton mm, equal to, now area. What is the area for cell 1? What is this cell 1? This FDEF. So what is the cell? This is the cell, right? 1. So what is the area? It is 200 and it is 300. So it is 200 into 300 and q1 is unknown. Then what is the area 2? It is 300 into 300. And what is unknown? q2. Now guys, try to simplify this. Try to simplify and tell me equation. So what will be equation? uh, 10 to the power 4 will get cancelled, so 6 will cancel, right? So 3. So what will be the equation? 6 12. So 12 12 will get cancelled. So it will be what? 100 equal to q1 plus 1.5 times q2, right? Am I correct? So whatever I have written, it is correct, Mr. Sivendra Raj, right? q1 plus 1.5, q2 equal to 100. So this is what my first equation, right? But we cannot find using single equation q1 and q2. We need one more equation. So the another equation will come from what? Compatibility of the displacement. So what is the compatibility of displacement equation? Your theta 1 dash will be equal to theta 2 dash. So what is the theta 1 dash, guys? We have written, right, earlier. What it is? 1 upon 2 a. What is the theta? So first, guys, theta dash, it is 1 upon 2 ag integration q ds by t. Am I correct? Is this formula correct? Yes or no? Yeah. So 1 upon 2 a1, because area is different. G is same. Then it is what? Integration q ds by t for 1. Now this is equal to what? 1 upon 2a to z integration q ds upon t for 2. Right? Now guys, t is uniform and t is same throughout. Yes or no? So this t will get cancelled. And material is same. So g will get cancelled. Now guys, what is your equation? It is 1 upon 2a1 integration q ds for 1 is equal to 1 upon 2a2 integration q ds for 2. Now guys, if you take cell 1, if you take cell 1, you can write here 1 upon 2a2. Or what I can do, I can write, guys, it as what? 2 will get cancelled, right? So it is what? a2 by a1. So a2 by a1 is how much? 2 got cancelled. a2 by a1 is 1.5. Yes or no? a2 by a1 is how much, guys? 900 by 600, right? Sorry, not 900. It is 9 into 10 to the power 4 upon 6 into 10 to the power 4, right? So I can write here a2 by a1. So a2 by a1, then it is 1 q ds is equal to integration q ds, and this is for 2. Now a2 by a1, we know what is the a2 by a1. It is 300 into 300 divided by 200 into 300. Okay, so from here it is 1.5. Am I correct? So you guys can write 1.5. Now guys, if you take section 1, so for section 1, if you see, I am starting from what? D to E. I am starting with, or we can start, yeah, for section 1 I am starting from D. So D to E, what is your shear flow, guys? D to E, what is the shear flow? D to E, my D to E shear flow is what? Q1, right? And what is the length? Length is 200. So it is what? Q1 into 200. Then guys, plus or minus. Here guys, this also important. It is minus because I am going D to E. Okay. Now guys, E to F. E to F. What is your shear flow? It is still Q1 and it is minus. So it is minus Q1. What is the length? It is 300. Now guys, we are going F to A. What is the shear flow? Minus Q1. Everybody understanding why minus? Because we are going in the opposite direction of shear flow coming. So it is minus Q1 into 200. Now guys, A to D. A to D. What is the shear flow A to D? It is Q2 minus Q1. Okay, if we are going A to D, so it is Q2 minus Q1. So it is plus Q2 minus Q1. And what is the length? 300. Okay, so this is what? Right hand side. Now left hand side. In left hand side means section 2. Section 2. So for section 2, we are starting from A. A to B. If you are starting from A to B, if you are starting from A to B, A to B, what is the shear flow, guys? Minus Q2. Minus Q2. Okay, into what is the length? 300. Then, guys, we are going B to C. Guys, B to C. Now, guys, one thing I want to tell you. When I have found theta 1 now, I have gone in opposite direction to shear flow. Okay, so you have to do same thing. Okay, you have to go same for 8 for section 2 also. For section 2 also, guys, you have to go in the same way. If you go for section 2 in a opposite direction, what is going to happen? See what I mean? I have gone in opposite direction, right? D to E, then F to A, right? So that means I am going considering my theta is what? Clockwise. So same way, theta 2 should be also what? Clockwise. Okay, so you have to go in the same way. Okay, that's why I started what? A to B. Now guys, B to C. B to C means what? Again, what is your shear flow? B to C, what is your shear flow, guys? Minus Q2, right? Same as AB, right? So you can write here minus Q2 into 300, then C to D. C to D what? Again minus Q2 into 300. Then guys, we are going what? D to A. So for D to A, what is your shear flow? it is Q1 minus Q2, right? If you write plus, or if you go with Q80, then it is again minus Q2 minus Q1 into 300, right? Clear, guys, how I have written this? Everybody, is it clear? Okay, now guys, simplify this. Guys, can you simplify this? So what we see, if you simplify, it is 200 plus 300, 500 plus 200, 500 plus 200, 700 plus 3000. So I will get minus 1500 Q1. Okay, then 300, so I will get plus 450 Q2 from this, and this side what I get, so minus 300, 900 and 1200, so I'll get minus 1200 Q2, then I'll get plus 300 Q1. Guys, check it, is it correct? Bye. So what I get? I get 1800 Q1 is equal to 1800 Q1 is equal to 1650 Q2. Am I correct? Is it correct, guys? Please check. Is this correct? So from here, what is your Q1? Q1 is equal to, or Q2, you can write Q2 in terms of Q1. So Q2 will be 1800 by 1650 into Q1. So guys, what we get? 1800 by 1650 is how much? 1 point. 1 point how much? 1.09. It is 1.1 around, right? Yes, it is 1.1 Q1. Okay, or better, don't approximate. It is 1.091 Q1. Is it correct? Q2 equal to this. Now guys, look your equation, the first equation, which is what? Q1 plus 1.5 times Q2 equal to 100. Am I correct? So from here, substitute that. So what we get? 100 equal to Q1 plus 1.5 times into 1.091 Q1. So guys, find out Q1 from here. How much you get Q1? 0.3793. Everybody, I don't think this 37.93, I think it is 37.92. So it is what? Newton per mm. Okay. Now what is the Q2 then? What is the Q2? It will be some 43 something, right? Guys, find out Q2. Yeah, it is 41.37. Now what is the QAD? It is Q2 minus Q1. So what it is? 41.41 38 minus 37.92, and they ask what? Tau AD. So what is the tau AD? By T by T. So you divide it by what is the thickness? 1.5 mm, right? What is the thickness? It is 1.5. Okay. Now guys, find out tau AD. It will be in megapascal. So how much stress? So tau AD was asked. So how much tau AD? 2.3 megapascal. Okay, so you guys can check. This question was asked in the recent paper in 2022. Okay, 2.29 or 2.3 megapascal. Now, guys, in this question, one thing you guys always have to take care. Okay, you have to go in the same direction when you equate angle of twist. Okay, what mistakes could have happened? Everybody got? Was it tough question? Even see, I have not used calculator, but majority of the calculation, yeah, of course it will take time, but majority, see, if you write every steps, many things are simple now. Majority of the calculation without calculator you can do. See, 1800 by 1650, still we can divide, right? Only one or two places calculator was required, yes or no? So guys, in exam you make sure you simplify as much, and then only you use calculator. Clear? See, where all calculator was required, in entire, only here calculator was required, right? And then to find, right, here we can do na, simple. Now what mistakes would have happened, that is what we need to do or discuss here. Usually, see, when you equate your theta 1 and theta 2, okay, theta 1 dash is equal to theta 2 dash. So guys, that time, make sure, see, I started d to e f a, means I went in the opposite direction of shear flows, right? So that means I am going like this. Consider my twist is in opposite direction, right? So that means for this and for this, we are equating angle of twist. We are not taking equilibrium of twist, right? Getting my point? So that's why you went in both the cells, we went in opposite direction of shear flow. You can go in the same direction of shear flow also, still you will get the same answer. That means what I mean to say, see, we have considered shear flow in the same direction of torque Q1 and Q2. Now, while finding theta 1, if you go in the same direction, so you start from A to F. We can start A to F, what it will be? It will be Q1 into 200, then F to E. What it will be, guys? F to E. It will be again Q1 into 300, and then again E to D is what? Q1 into what? 200, and it was outside multiplied by 1.5, right? Then D to E, what it will be now? Plus or minus? It will be minus QAD, right? So what is the QAD? It is Q2 minus Q1 into 300. Now guys, this should be equal to what? We have to go in the same direction of shear flow. That means D2, we will start from D. So D to C. So what is D to C? It is Q2 into 300. Then C to B is what again? Q2 into 300, and then plus Q2 into 300 for what? B to A. Then A to D. A to D is what? Plus. So it is what? Q2 minus Q1 into 300. Clear, guys? Is this point clear? So guys, make sure this need to be followed when you are equating angle of twist, or if you are using compatibility. Clear, everybody? This question, yes or no? So guys, sometime they are asking lengthy question, right? Because in a previous year, in 2017 paper, this I think guys came in 2021 paper. Okay, 2021 or 2022. I think in 2021 paper, because that paper was lengthy. But it is not a tough question, right? In fact, if you solve the shear flow question, unsymmetrical bending question from this Maxon book, they will be much more, lengthier than this question. Because at least, luckily, in these questions, we don't require to find any cross-sectional properties. Only thing, you need to make one algebraic equation out of compatibility and then solve. So still it is not that lengthier. Okay, so let's move to last question in thin wall structure, numerical